Climate. What is climate? A region's climate is defined by year after year patterns of temperature, humidity, and precipitation. Weather is the day-to-day condition of Earth's atmosphere. Climate refers to average conditions over long periods and is defined by year after year patterns of temperature and precipitation. Climate is rarely uniform, even within a region. Environmental conditions can vary over small distances, creating microclimates. For example, in the Northern Hemisphere, south-facing sides of the trees and buildings receive more sunlight and are often warmer and drier than north-facing sides. These differences can be very important to many organisms who live on the south side. Mountains in the next slide show these significant differences. So moist rising air, wind often off the ocean, cause the clouds to form and precipitation fall. And the rain shadow region is where these clouds have given off all their moisture. And on the descent, this is dry air because it's already given off all of its moisture. What factors affect global climate? Global climate is shaped by many factors, including solar energy trapped in the biosphere, latitude, and the transport of heat by winds and ocean currents. The main source that shapes our climate is solar energy that arrives as sunlight that strikes the Earth's surface. Some of the energy is reflected back into space and some absorbed and converted into heat. Sunlight hits, reflected off the atmosphere, reflected off the Earth itself, and some is lost back into space, re-radiated as heat. These greenhouse gases will trap some of the energy and re-radiated back to Earth and absorbed and retained in the atmosphere. And some is absorbed in the Earth's surface itself. A lot like a greenhouse, the light will come in and then bounce back off the glass to keep inside the greenhouse. And these greenhouse gases are very significant and help the Earth. Some of the heat is radiated back into space and some trapped in the biosphere. The balance between the heat that stays in the biosphere and the heat lost to space determines Earth's average temperature. Earth's temperature is largely controlled by concentrations of these three atmospheric gases: carbon dioxide, methane, and water vapor, clouds. These greenhouse gases function like glass in a greenhouse, allowing visible light to enter but trapping heat through a phenomenon called the greenhouse effect. If greenhouse gas concentrations rise, they trap more heat, so Earth warms. If their concentrations fall, more heat escapes and Earth cools. Without the greenhouse effect, Earth would be about 30 degrees cooler than it is today. That would mean most of the Earth would be frozen. Near the equator, solar energy is intense, as the sun is almost directly overhead at noon all year. That is why equatorial regions are generally so warm. Polar regions in winter receive almost no light and no sunlight directly overhead during the summer. The curvature of the Earth causes the solar energy to spread out over much larger area near the poles than near the equator. So the poles are receiving much less sun per square area. The difference in the heat distribution create what is called three different climate zones: tropical, temperate, and polar. The tropical zones, which include the equator, is located between 23.5 north and 23.5 south latitudes. This zone receives nearly direct sunlight all year. On either side of the tropical zone are the two temperate zones between 23.5 degrees south and 65.5 degrees north. Between 25 between 23.5 degrees south and 66.5 degrees south, and also between 23.5 degrees north and 66.5 degrees north. Beyond the temperate zones are the polar zones between 66.5 and 90 degrees north, and also in the southern pole, so both poles. Temperate and polar zones receive much less solar energy at different times of the year. During winter and in the temperate and polar zones, the sun is much lower in the sky, days are shorter, and solar energy is less intense. As Earth revolves around the sun, solar radiation strikes different regions at angles that vary from summer to winter. So in June, it's faced this way. With that tilt, you have different seasons. Heat transportation, the unequal distribution of heat across the globe creates wind and ocean currents, which transport heat and moisture. Earth has winds because warm air is less dense and rises, and cool air is more dense and sinks. Air that is heated by warm areas on the Earth's surface, such as near the equator, rises and expands and spreads north and south, losing heat along the way. So this heat would be built up, rising, and then go north or south and cool down. As the warm air cools, it sinks again. In cooler regions near the poles, chilled air sinks toward the Earth's surface, pushing air at the surface outward. So as it cools, it will sink and then it pushes outward. The air warms as it travels over the warmer surface of the Earth and then rises again. These upward and downward movements of air create winds. Winds transport heat from regions of rising warmer air to regions of sinking cooler air. Earth's rotation causes winds to blow generally from west to east over the temperate zones and from east to west over the tropics and the poles. This way and this way. Similar patterns of heat and cooling occur in the oceans. Surface water is pushed by winds. Ocean currents, like air currents, transport enormous amounts of heat. Warm surface currents add moisture and heat to air that passes over them. Cool surface currents cool air that passes over them. In this way, surface currents affect the weather and climate of nearby land masses. Deep ocean currents are caused by cool water near the poles sinking and flowing along the ocean floor. The water rises in warmer regions through a process called upwelling. Of the air, another picture of how the air transports from east to west on the equator, flowing back in the temperate zone and back again on the poles. As the currents in the ocean can cause this tornado in the ocean, dust collected in the tornado space. And here, probably familiar with this, but one of the reasons that the tide rip current cause is because that current is always flowing and sometimes they collide and then push the water back out where the waves normally come in. At points where the certain waves combine, they'll actually pull you back outside. So if that happens, you swim parallel to the beach, either this way or this way, to get away from that rip current.